this video we're gonna talk about the 6-pack instruments and the other instrument or gauge such as tachometer and oil pressure and temperature gauge. Without further ado, let's get into it.
So let's start in airspeed indicator. Its function, display the aircraft's airspeed in knots or miles per hour. So how it works? Connected to the pilot static system, it measures the dynamic pressure difference between total and static pressure, and the reading is calibrated to indicated airspeed.
Attitude indicator or artificial horizon. Its function shows the aircraft orientation relative to the horizon. It can be pitch and bank angle. This is how it works. Uses a gyroscope to maintain a fixed reference. The instrument face displays the horizon line with a movable aircraft symbol indicates the aircraft altitude.
So let's move to altimeter. So the function of altimeter is that it displays the aircraft's altitude, or above mean sea level, or MSL. So how does it work? So it uses the static pressure from the phytostatic system. The instrument contains aneroid wafer that expand or contract as static pressure changes, moving the needles to indicate altitude.
Turn coordinator. Function. It indicates the rate of turn and slip or skid condition. How it works. It operates with an electric gyroscope for turn rate and an inclinometer to indicate slip or skid. A coordinated turn keeps the ball centered. Heading indicator. Function. Displays the aircraft's heading relative to magnet north. How it works. A gyroscope provides a stable reference for heading. It requires periodic alignment with the magnetic compass because of gyroscopic precision and drift.
So let's move to vertical speed indicator, or what they call VSI. So the function of vertical speed indicator, or VSI, is that it indicates the rate of climb or descent in feet per minute, or FPM. So how does it work? It measures changes in static pressure. A calibrated leak allows the pressure to stabilize, creating a differential that shows vertical speed.
Tachometer or RPM indicator. The primary purpose of tachometer is it indicates the engine's RPM, allowing the pilot to monitor the engine health, set the appropriate power for different phases of flight. For example, takeoff, cruise, and landing. So the question now is, how does it work? The tachometer can be driven mechanically, electrically, or electronically, depending on its aircraft type. Next is the aircraft oil temperature and pressure gauge. These gauges monitor the health of the aircraft's engine by displaying the oil temperature and pressure, which are critical for proper lubrication and cooling. The primary function of oil temperature gauge displays the temperature of the engine oil, ensuring it stays within safe operating limits. So, how does it work? It uses a thermocouple or a temperature-sensitive bulb filled with liquid. The thermocouple generates an electric signal based on the oil's temperature. Signal is processed and displayed as a temperature reading. Next is the oil pressure gauge. Its primary function is to display the oil pressure in the engine, ensuring sufficient lubrication to prevent engine damage. So how does it work? Connected to the engine's lubrication system, a Bourdon tube or electrical transducer measures oil pressure. Pressure changes cause the tube to deform or generate a signal, moving the needle or displaying the value electronically. The aircraft fuel quantity gauge. The fuel quantity gauge indicates the amount of fuel in the aircraft's tank, helping ensure the safe and efficient flight planning. So how does it work? A fuel sensor located inside the fuel tank can be a float type. A float moves within the fuel level, adjusting the resistor to vary the electrical signal. And a capacitance type measures changes in capacitance caused by varying fuel levels. The sensor sends an electrical signal proportional to the fuel level to the gauge. The gauge processes the signal and displays the fuel quantity either via a needle or a digital readout. Let's talk about the integration inside the aircraft. These instruments function through two primary systems, the pitot-static system and the gyroscopic system. A pitot-static system feeds data to the airspeed indicator, altimeter, and VSI, measures air pressure to calculate speed, attitude, and climb or descent rates. Gyroscopic system powers the attitude indicator, heading indicator, and turn coordinator. It relies on gyroscopic principles of rigidity and precision for stability and movement. By combining data from these instruments, pilots maintain situational awareness and control the aircraft during flight, ensuring the operational safety and efficiency.